This is MSJ Chem. In this video, I'll be looking at a comparison of SN1 and SN2 reactions. So we'll start by looking at the class of halogenoalkane. Tertiary halogenoalkanes react via the SN1 mechanism. Primary halogenoalkanes react via the SN2 mechanism. Next is the number of steps. SN1 is a two-step reaction. SN2 is a one-step reaction. Next, we have transition state or reaction intermediate. The SN1 mechanism involves the formation of a carbocation intermediate. The SN2 mechanism involves the formation of a transition state. Next is type of solvent. The SN1 mechanism is favored by polar protic solvents. The SN2 mechanism is favored by polar aprotic solvents. Next, we have type of bond fission. Both the SN1 and SN2 mechanisms involve heterolytic bond fission. Next, we look at the molecularity. The SN1 mechanism is unimolecular. This is what the 1 stands for in SN1, substitution nucleophilic unimolecular. SN2 is bimolecular, substitution nucleophilic bimolecular. Next, we look at an example rate expression. So for SN1, we have rate equals K and the concentration of the halogenoalkane only. For SN2, we have rate equals K and the concentration of the halogenoalkane and the nucleophile. Next, we have relative rate of reaction. For SN1, tertiary halogenoalkanes react faster than secondary halogenoalkanes, which react faster than primary halogenoalkanes. For SN2, primary halogenoalkanes react faster than secondary halogenoalkanes, which react faster than tertiary halogenoalkanes. And finally, we have the change in stereochemistry. For SN1, the products are a 50-50 mix of enantiomers. This produces a racemic mixture which is optically inactive. The SN2 reaction is stereospecific. There is an inversion of configuration, which means the product is optically active. And finally, we'll compare the SN1 and SN2 reaction mechanisms. So as we can see, the SN1 mechanism is a two-step reaction. The first step involves the formation of a carbocation. In the second step, the nucleophile bonds to the carbocation. The SN2 mechanism is a one-step reaction. The nucleophile attacks the halogenoalkane via a backside attack. In the transition state, both the nucleophile and the halogen are weakly bonded to the carbon atom. We then have the formation of the product, which shows the inversion of configuration.